Hello students! Today, we will be discussing the part 1 of structured programming. Specifically, we will be discussing the decision or selection structures. I am your course instructor, Engineer Eldon P. De Padua, and let's start exploring our topic for today. At the end of this lesson, you are expected to first understand how different program structure works. Second, construct algorithms using program structures, and lastly, evaluate algorithms which contain program structures. Let's begin with the if-then statement. If-then statement is a conditional statement used in directing program flow based on multiple decision criteria. It has an equivalent English form of if such and such is true, then do so and so. This programming structure is one of the commonly used programming structure in different programming applications, such as but not limited to web development, control systems, robotics, mechatronics, computer vision systems, and the like. We have different forms of if-then statements. Generally, we have the single selection and the multiple selection. For single selection if-then statements, we have the single line if statement and the if-then statement. For the multiple selection, we have the if-then-else statement, the nested if-then-else statement, and the if-then-else-if statement. So when do we use the single selection if-then statement? We use it whenever we only have one condition and one or more statements afterwards. So here are the syntax that we use for single line and if-then statements. For the single line syntax, we use if a certain condition exists or is satisfied, then do a specific statement or a specific task after that. For the if-then syntax, we use if a certain condition exists or is satisfied, then do the following statement. So it could be two or more statements as a result of satisfying the condition, the former condition. And we close our logical statement by writing and if at the end. In the former form of the if-then statement, which is the single selection if-then statement, the logical statement that does nothing whenever the statement or the condition in the if statement is not met. But for the multiple selection if-then statement, the logical statement does something whenever the condition in the if statement is not met. For example, here in the if-then-else syntax, we write it this way. Our logical statement looks like this. So if a certain condition exists or is satisfied, then do something. So in case that we don't meet or we don't satisfy the condition, we put here another syntax else. Okay, so else will encompass or will encompass the task or the responses whenever the condition in the if statement is not met. So in that case, whenever that our condition is not satisfied, it will read the corresponding responses under the else statement before it will end the logical statements by writing and if. Another sophisticated form of the multiple selection if-then statement is the nested if-then-else syntax or statement. So when we say nesting, it is the process of embedding program statements in other statements. Beside is the syntax for the nested if-then statements. So here's an example of the nested if-then-else statement or syntax. So let's say we have condition 1. So if this condition 1 is satisfied, then we do specific statements or specific tasks. But if it does not satisfy the condition 1, we have here another criteria or logical statements that our program follows or reads. Okay, so in case that happens, so we have here the logical statement: if condition 2 is satisfied, then do the following or do specific statements or tasks. And it doesn't end there, but after it, or part of the tasks or statements that it will do after satisfying condition 2 is another criteria, which is represented or described by this logical statement: if condition 3 is satisfied, then do specific tasks as well. So we write "and if" here to end our or to close our if then statement for condition 3, and we put here else on the level of the if statement under condition 2 in order to write an alternative response or task or statement whenever that condition 2 is not met. And lastly, we write here "and if" on the level of the if and else statement in condition 2 to close or end the logical statement under condition for condition 2, and another "and if" on the level of if then else statements for condition 1 to end the program statements for condition 1. Lastly, we have the if then else if syntax. We also use this whenever we have to specify several conditions in just one if else statement. So let's have here an example. So if condition 1 is met, then we do a specific task, but if it is not met, then we introduce here another criteria: else if condition 2 is met, then do the following statement. But in case condition 2 is still not met, then we use or we proceed to another else if statement, wherein if here it's stated that if condition 3 is met, then we do the following statements. So in case that condition 3 is still not met, then we do nothing, since we already write here an "and if" syntax. Let's have here an example of the if statement using Python. Here, the program evaluates the test expression or condition and will execute the statement only if the test expression or condition is true. If the condition is false, or if the test expression is false, the statement is not executed. In Python, the body of the if statement is indicated by the indentation. The body starts with an indentation, and the first unindented line marks the end. Python interprets non-zero values as true, while none and 0 are interpreted as false. In this example, num greater than 0 is the test expression or the condition. The body of the if statement is executed only if this evaluates to true. When the variable num is equal to 3, for example, the test expression or the condition becomes true, and statements inside the body of the if syntax are executed. However, if the variable num is equal to -1, the test expression or the condition is false, and therefore, statements inside the body of if syntax are skipped. The print statement falls outside of the if block. It's unindented, if you can see. Hence, it is executed regardless of the test expression. Whenever you run the program here in the example or presented here, the output will be 3 is a positive number. This is always printed. This is also always printed. So you can see this output when you use an IDE for Python. For example, is the PyCharm, or you can see it in the console of that IDE. This time, let's look at an example of an if-else statement syntax using Python. The if-else statement evaluates the test expression or the condition and will execute the body of if statement only when the test condition or the test expression is true. If the condition is false, the body of else is executed. Indentation is used to separate the blocks. Let's say, for example, in the slide, when num is equal to 3, or when your variable num is equal to 3, the test expression is true and the body of if is executed and the body of else is skipped. However, if the variable num is equal to -5, the expression becomes false and therefore the body of else is executed and the body of if is skipped. Nonetheless, if num variable is equal to 0, the test expression is true and body of if is executed and while the body of else is skipped. When you run the example program using PyCharm, you will see the output positive or 0. Let's have here another example, but this time for the if else statement syntax using Python. We use the syntax elif, which is the short term for the else if syntax, and it allows us to check for multiple expressions. So in this example, if the condition for if is false, it checks the condition of the next elif block and so on. If all the conditions are false, the body of else is executed, just like the previous example. And only one block among the several if, elif, or else if, else blocks is executed according to the specific condition. The if block can have only one else block here, but it can have multiple elif blocks on the other hand. When variable num is positive, the word positive number is printed. However, if num is equal to 0, the word 0 is printed. And lastly, if variable num is negative, the word negative number is also printed. So take note here that the initial value of your variable num is equal to 3.4. So whenever you change this one, then it will print to the console. It will print to console the corresponding what do you call it, this corresponding statement based on the conditions that you have set in your if, else if, or elif and else statement. So let's say, for example, you run this program, sample program in PyCharm, then you will get, you will see in the console the word positive or 0 as your output. Moreover, we can have an if, elif, else statement inside another if, elif, else statement. And we call this nesting in computer programming, just as what we've discussed earlier. Any number of these statements can be nested inside one another. Indentation is the only way to figure out the level of nesting. That's why it's very important that when you write your code using, not only using Python programming, to observe indentation so that you will not get confused with the level of nesting, and you can just easily follow or trace up whenever you do debugging or when you review your program. Okay, so let's have this example. If you can see in the example here, we have an if-else statement, and inside an if-else statement is another if-else statement. So for the higher level if-else statement, our condition there is our variable num should be greater than or equal to 0. So whenever your variable has a value that is greater than or equal to 0, then it will read the body of the first if statement, which is another if else statement. So in this case, the condition for the if else statement is when the variable num is equal to 0. So whenever this happens, whenever the case is the value of num variable is equal to 0, then it will print 0. So else, if it's not equal to 0, it will print positive number. And then if the if the condition if you don't meet the condition num greater than or equal to 0, then we just simply print the word negative number. Okay, so in case you might ask, what's the purpose of using the syntax float here? So we use float input syntax here so that we can type whatever value or whatever value we want to assign to variable num using our console in PyCharm or other IDE, programming IDE compatible sa Python. Okay, for example, here suppose we enter in the console the number 5. So since 5 is greater than or greater than 0, hence the if else statement in the body of the previous if statement or if else syntax will be read. And since it's greater than 0, then we will print, since it's not equal to 0, it's 5, and it's greater than 0, hence it will print in the console the word positive number. Okay, but if you're going to write or enter -1 in your console, so since it does not satisfy the condition in the first if statement, hence it will print it will print the term or the word negative number in your console. Nonetheless, if you try to enter the value 0 in your console, it would read the body of the if else statement where the condition is num greater than equal to 0, and it will just print the word 0. Another programming structure that we're going to discuss is the select case statements. Select case statements is very similar to that of the if then statements, only that it's more efficient sometimes than the if then statements, depending on the conditions or the objectives of your program. So select case decision structure provides a cleaner alternative for single value comparisons against a list of several objects or a single object compared against different values. So the syntax for select case statement is as follow. So we have there select, the syntax select, then you put your case there, then the condition or the test expression. Then after you have identified what condition will be the basis for your cases, we then specify our cases. So we can write here our case for expression list number 1. Then under that case would be the following statements. So in case that the condition falls on the first case or the case expression list 1, it will do the following statements or the statements 1, the first statements. Then if ever that the test expression or the expression satisfies the conditions indicated in case expression list number 2, then it will also do some corresponding statements or tasks. And else, if none of those specific cases that you have written has been satisfied by your condition, then it would you could write case L syntax, wherein you can write here the alternative statements or tasks that you want your program to do when that case or when when your condition does not satisfy any of the specified cases. And after that, to close the select case syntax, select case um, statement, you can just type and select syntax. In using the select case statements, note that the list expression can be any of the following. So first, it could be an exact value, for example, case 1. So this is the case when the initial condition or value of your variable is equal to integer 1. And second is that it could be at different values. For example of that, case for values 1, 5, and 9. And it could also be ratio values. For example, case where values are from 2 to 5 and it could also be a condition. For example, our case is greater than, or the value of a case wherein the value of your variable could be greater than or equal to 2. Okay, take note that for select case statement wherein the list expression is a range of values, the keyword to is used to specify the boundaries of a range of matched values for test expression, while the keyword is used with a comparison operator equal, greater than, less than or greater than, pwede rin, pwede ding less than lang or less than equal to, greater than or greater than or equal to, para to specify restriction on the match values for test expression. If the is keyword is not supplied, it is automatically inserted before comparison operator. Let's take this for an example of the select case statement. The code on the right illustrates that a variable int output is evaluated against different values. So if you can see in the first two lines, we are just simply defining there our variables, wherein the SNG input is a single type variable, meaning to say that the value of our input could be an integer or a non-integer, while the int output is we define it as an integer, meaning to say it will always be a whole number. For the third and fourth line, we just simply meant there that the value of our int output variable is dependent on the whatever value we put on the SNG input variable, and that in order to get the value of int output, we need to get the quotient of the variable SNG input and 7. But in this case, since we use the operator backlash, it means to say that whatever result we can come up after dividing the SNG input by 7, we need to round it up. We need to round it to the nearest integer. So it could be round up or round down depending on the value of the value of the quotient. And then since we use here the syntax mod, meaning to say that whatever quotient we get from this SNG input and 7, we also need to divide it to 7, and then the remainder of the 2 will be the value of our int output. So let's take for example, we have here the input 100 SNG input equals 108. So if you're going to put 108 here in our SNG input, so that would be 108 divided by 7, so that's around 15 point something. So we will just add a 15 there. So 15 divided by 7, so that would be mm, 15 divided by 7 is equal to, yeah, that's 2 point something. Yeah, okay. So if you're going to round it up to uh, get the remainder, rather, that would be 1. Yeah, 7 times 2 is 14, so the remainder is 1. Okay, so later on, we will know what would be the implications of that value of the int output. Okay, so let's proceed, or let's proceed here in the select case statement. So select case int outputs, or int output here is our basis or our condition. So this is the basis of our cases. So the cases that we have here is, first, for case where the value of int output is less than 0. So the background of the form is shown here in the lower left of the presentation, the window that you can see here with the word input, output, and show. So the background of that form would turn into red if the value of int output is less than 0. Meanwhile, if the value mm, of the int output is between 1 and 2, integers 1 and 2, so the color of the form would turn into blue. On the other hand, if the value of the int output is less than or equal to 3, then the background would turn into green. And for case where the value of int output is equal to 4, the background would turn yellow. And for values greater than 5 for int output, the background will turn into pink. So in cases where none of the cases is satisfied by the the resultant value here in our int output, so we have here an alternative um, response or alternative result. So the color would be just an empty color. And after that, after that, uh, to close the statement or the program statement, we just write here and select. Okay, so lastly, we can actually convert our if then else statement into select case statements, or the other way around. Let's take, for example, this code here, or this program statement presented here. So we have our variables int a, int b, int c, which is defined here as integers, and variable bln decision as boolean variable. Okay, so initially we have values for our variables int a, int b, and c, which are -5, +3, and -2 respectively. And we have here our if then else statement and the select case statements. So let's take a look first to the if then else statement. So in order for us to test whether the Boolean decision is true or false with the given values of integers a, b, and c, or variables int a, int b, and int c, so we have this test condition or the test expression. So here it states that if variable int a is less than 0, or the value of int b is greater than 0. Anyway, XOR means that um, the condition for int b cannot be true at the same time with the condition of int c. So, bale, int b greater than 0 cannot be true if int c less than 0 is also true. Okay, so if both of them are true, then um, the result of this syntax, or of this logic rather, XOR, would be false. So, but if int b greater than 0 is true, while int c less than 0 is false, then the result of this XOR logic would be true. Okay, so yeah, that's how you interpret that. And then also, if the value, any of the two conditions. So I'm referring here to the condition of int a less than 0 and the condition of the XOR logic is any of them is true, then the Boolean decision would be true. But if both of them are false, then the Boolean decision would refer to the else statement, which states that the Boolean decision in that case would be false. Okay, so yeah, we put and if here in order to indicate that our program ends after it reads the following logics or conditions. And then we put also console that right line Boolean decision in order to print out or show our result or output in the console or monitor. Okay, so let's have here, as we've said earlier, and we have the initial values for int a, int b, and int c, which are -5, 3, and -2. So if you're going to substitute it here, so int a, that's -5, that's less than 0, so this is true. Int b greater than 0, so int b is +3, so that's greater than 0, so this is true. Int c is -2, that's less than 0, so that is as well true. So since our condition for int b is the same, it's true, and it's the same with the condition of int c, which is also true, then the product or the result of our XOR logic here would be false. So even though it's false, but since our int a less than 0 is true, hence it should give us a Boolean decision that is true, equal to true. So the word true would reflect on our console. Okay, so we can do the same using select case statement. So here it just states that the case would only be true if this is the case. So the case here that we are referring is that when int a or variable int a is less than 0, or or our int b is greater than 0, and XOR int c is less than 0, or either of the conditions of int b and int c is true. So in this case, since if we're going to use the same values for our variables, we could get true here for int b and true for int c. So the answer or the result here for our XOR logic would be false, but our int a would remain true because -5 is less than 0. And since we put here that for that case the Boolean decision would be true, hence you would expect that the end result of our program would be program statement would be true. So anyway, in cases that the inputs or the values of our integer variables do not satisfy the case indicated here, so we have an alternative decision here under the case else syntax, which states that for that case the Boolean decision would be false, and we put end select to end the program statement, and also we put console.write line Boolean decision and console.read line close open parenthesis to project our answers in the console. So that's all for our lesson for today. So these are the resources that I've used in preparing this lesson. And for your assignment, the select case statement in Visual Basic has an equivalent statement in Python programming and other programming languages. So for your assignment, kindly do a research on how to implement a switch case statement in Python. So still, you are free to use whatever format for your written report. And for strict compliance, please upload your reports in our Moodle classroom. So again, I am your instructor, Engineer LMB de Padua, saying thank you very much and see you next meeting.